Welcome to FMA 0116 Mathematics 1. This video is about inverse of matrices. Over here, we are going to cover a matrix 2 times 2 and 3 times 3. And we are going to use two different methods. One is adjoint methods and the second one is elementary row operation. Okay, so what is an inverse matrix? Inverse matrix that is when you have any square matrix, A times B and equals to B times A, and the product of the multiplying of both matrices is an I. So we can say that is A is the inverse of your B, or we can say B is the inverse of our A. Okay, now, and we have to remember that the way to write an inverse of a matrix is A minus 1. And please remember that this is not A over 1. Okay, this is a matrix. Okay, now let us change our B to become an A inverse. So when you means that you are multiplying matrix and the inverse, and the inverse multiplying with the matrix, you will give you the identity. Okay, now if your A inverse exists, we call the A as an invertible or called non-singular matrix. Okay, but when your determinant is 0, your A inverse does not exist. Why it does not exist? Later on, you will know that. Okay, so A is called singular matrix. Okay, now, so it means that to avoid your inverse does not exist or you're trying to do something wasting your time, so always do a check for the determinant. Okay, make sure your determinant is not equals to 0. Okay, now, so we look at the inverse of a 2 times 2 matrix. Okay, so now back to the previous one. When it said that when it is a singular matrix, the determinant cannot be 0. If you see here that we finding the inverse is 1 over the determinant. If 1 over 0 will give you the max error or the undefined, so means that this inverse is does not exist. Okay, so the first thing that you have to ensure you have an inverse is mean that you must have a determinant that your determinant cannot be 0. It can be negative but cannot be 0. Okay, so let us look at 2 times 2, a matrix 2 times 2. So the determinant, as we discussed before, is an AD minus BC. And what is the determinant? We interchange the place of A and D, and the place of negative B and C, we are putting the sign of negative. Okay, actually this formula is formed by using adjoint matrix. Okay, now how you want to find the matrix using adjoint matrix? Let us recap back. We have our matrix A, B, C, D, E, F, G, H, I. So first thing, still remember how to find your minor. Your minor is found by, okay, if you want to find your M11 means that you cover your ADG, ABC, so you have the determinant of EFHI, and you find 9 of them. After that, you put the sign, alternating the sign plus, minus, minus, plus, and so on for the 9 of them. So you have the cofactor. Okay, now we are going towards adjoint matrix. Matrix is obtained by transposing cofactor matrix. It's very simple. So means that you just, okay, you just transpose, okay, so M11, okay, you just transpose your adjoint. Okay, so after that, you just, how to find your inverse? A inverse is still the same, is 1 over determinant adjoint A. So this is your inverse matrix. Okay, so actually the hard work of your finding inverse matrix using adjoint matrix actually is the place you finding your minor matrix. Okay, let us look at our first example. 1, 2, 3, negative 1, 5, 7, 4, negative 0. Remember how you find your minor? Okay, so covered. Okay, so you have your 9 matrix, 9 determinant here. So I have my matrix minor. After that, we using the alternative sign. So we have the negative and so on. Now, how to find your okay, after that, we find our determinant. Actually, we already found this one before. It's usually is a 16. Now, how to find our inverse? A inverse is 1 over determinant, 1 over 16. Okay, at join, we learned before, just transposing your C. Okay, so we just copy back ours. This one, putting C. So that's mean we just copy this one. Okay, this is your inverse. Okay, now in certain books they will put the 16 inside, because for me that is sometimes it looks quite ugly, so that's why my 1 over 16 is at outside. Okay, now we look at how to find your inverse matrix using elementary row operation. Okay, in elementary row operation, you have three different operations that you can use. The first one is interchanging two rows or two columns. Okay, basically in your books that they are only going to use the two rows. Okay, actually you can do the column too, but the thing is normally people are doing the rows way. So you can, okay, how to write interchanging two rows or two columns? Okay, if you want to interchange row 1 and row 3, so that's why you're writing row 1 interchange with your row 3, okay, and put an arrow. So you have a new matrix. So my row 1 and row 3 are interchanged. My second row is untouched, okay. And how about this one? When I interchanging my C2 and C3, so I interchanging both of them. Okay. The second operation here is you multiply a row or column by a scalar k. Okay, so means that when you writing, you multiplying k, okay, with your row 1 and you put back to your row 1. Okay, actually, when we the arrow R1 means that you put back into your R1, so you are replacing your row 1 with KA, KB, and KC. And the last one of our row elementary row operation, okay, this is the one doing the much work. Okay, so let's say you want to multiplying your row 1, okay, and add it into your row 2. So that is how we say it as you are multiplying your row 1, okay, with a scalar k, and you want to add it to your row 2 and replace with your row 2. Okay, and remember here that is we only can be, okay, row 2, the one you want to replace is untouched, okay, and you always will be adding someone to you. Okay, so this is the third row operation. Okay, now let us look at finding our inverse matrix elementary row by using ERO. Find the inverse of this one. Okay, actually it's the same example as previous. The first thing you have to do is you need to write your matrix in the augmented form. Okay, means that your matrix, whatever matrix you want to find, is A, and the writing the identity on the right hand side and separated by a bar. Okay, so you have two matrices combined. Okay, now first thing, so then after that you want to change your augmented matrix AI into IB. So means that your left hand side must be the identity using all the three. Okay, the combination of the three ERO just now. Okay, so what you need to do, basically, if you want to get I at the left hand side, means that your left hand side is 1 1 0 0 0 0 0 0. Okay, so basically, you first thing you have to make sure your lower triangular must be all 0. Okay, the all 0 must be all 0. You will obtain an upper triangular. After that, you will do to kill off the upper one. So make all three are 0. Okay, so let us look at it. First thing to be uh, secure, make sure your first element A11 equals to 1. Okay, our example, this one is 1. Okay, so the first thing to want to get the left hand side is the identity. So first thing we have to make sure these two are 0. Okay, how you want to get these two become 0? So we use the first row, okay, multiplying with something to kill the negative 1 and 4. Okay, so now we try to kill negative 1. So what we do is we use the A to 1, the element here, okay, multiplying with your row 1, Okay, because this is 1, so it doesn't matter. Sorry, this is value 1. So this is the main reason why we want to ensure our first entry element is 1. So you just use your A21, the one you want to kill, multiplying with negative, okay, and plus with your R2, right back to your R2. Okay, remember this one must be positive, cannot be negative. Okay, so this is your R21, so this is negative. Okay, so how you get it? So row 1, okay, because R1 negative negative is still R1 plus R2 right to your R2. So, okay, and because it's plus, so you just sum it. So this is the value. What you do, you write back to your R2. So your row 1 unchanged, your row 2 now is become 0, 7, 10, 1, 1, 10. Okay, you have to do for the whole row. Okay, this is the value. Okay, now how you want to kill 4? How you want to kill 4 is you use the 4 multiplying with the negative, and then you multiplying with your row 1, sum to your row 3, go right to your row 3. Okay, now our 4 by multiplying implies negative. So I have negative 4R1. This is the value. The whole row I'm multiplying with negative 4. And the R3 untouched, writing here. Then I sum them. This is the value. Okay. After that, write to your row 3. So now, after the two process, you have your new augmented matrices. Is this one. Okay. Now, after that, you want before you can kill the negative 10, so what we do is we just make sure our A22 equals to 1. How we can do it? One way is we just dividing the whole thing by 7. So, and right back to our R7. So, every 1 divided by 7. So, you have an ugly one. 0, 1, 10 over 7, 1 over 7, 1 over 7. Okay. Please make sure if you want to ensure your answer will be nice, so please keep it in a fraction. Don't use 1.7 and so on because you will lose the accuracy. Okay, after I already have 1, so now how do am I going to kill off my negative 10? What you do? Just take the negative 10, multiplying with negative, multiplying with my row 2, right to my plus with my row R3, right to my R3. Remember, this one is unchanged, okay? So you want to do so. So I do that is what I said just now. Okay, so we take our, because minus minus is positive, so that's why I have a tens R2. This is the value. And plus with my R3, then use calculator, you calculate, and this you'll be getting. Okay, so now you look at it. Now you already have 1, 1. Okay, the only thing here is not 1. So as like just now we can do, we just multiplying 7 over 16, you can change it to become 1. Okay, but we already obtained our first mission. All three are 0. Okay. So make sure A33 equals to 1. So multiplying with 7 over 6. So we get 1. So make sure you're multiplying everything. Now our duty is make sure the 3 up are 0. So we work backward. Okay. So we use this one to kill the 2 down here. Okay. Maybe certain books, they are start killing from here, but we can systematically moving out back here. So we are using the same thing. Okay. So how you want to kill this one? Just use the, okay, this is I kill the R1 first, okay, the row 1, the 3 here first. So we multiplying negative with negative 3, right back to your R1. And we doing, so right back to the row 1. After that, we multiplying negative 10 over 7. So you write to the row 2. Okay, now, please forgive me for the not accurate for the row alignment. Okay, now I already have lower down 3 0, this 2 0. So now I need to kill my 2. Okay, so how you want to kill your 2? Same thing, negative 2 R2 plus R1 going down. So now basically I have a lower down 3 and upper 3. Okay, this will be my inverse. Okay, this will be my inverse. Okay, it will be same as the previous one, but this one, because I already started with fraction, so you will see that this is a very messy one with all the fraction. Okay, and how you want to verify your answer? Okay, the formal way is use this A inverse, multiplying with your question A, you should getting identity. Or the other one is just key into your calculator, you can find the answer. Okay, now we look at another example. Let's say I have a 3, 2,